Hi everyone and welcome back to our channel. In this video we are going to talk about a very powerful and controversial feature of the Java programming language generics, which allows us to write generic code that can be used with different types of objects. So we will see what is generic code, what do we mean by different type of objects, everything. Here is a brief outline of what we are going to cover. We'll start with the problems with raw code and we'll see what raw code means here. Then we'll see how generics solve these problems. We will also see how to create generic classes and methods from scratch. We'll see how to use them. Then we'll see the concept of type eraser in generics. After that, we'll see subtyping and what wildcard means. So if you ever saw the question mark and extension super, this is what we are going to discuss in this section. And after that, the benefits of using generics. So let's start. Before we understand the concept of generics, let's take a look at a couple of examples and we will try to understand the limitations or the problems with the examples, and then we will move on to the generics and we'll see how generics solve these problems. Okay. So here on the screen, you see the example number 1. This is a simple class, sum calculator. It has a public static method with return type integer. The name of the method is sum and it accepts an integer array. And in the body, what we are doing, we are initializing a variable sum equals to 0. Then we are iterating the array and we are simply adding all the integers to this sum, which means we are calculating the sum of all the integers that we are passing to this method. And then in the end, we are returning the summation. So if I try to access this method, what I will do, I will call sum, then we need to pass an integer array to this method. So let's do that. That's it. And we can print this result. So we see the output 12, which is the sum of all these numbers. 2 plus 4, 6 plus 6, 12. So we have a method that accepts an integer array and it calculates the sum of all these numbers, then return an integer value. Now this method works fine with integer array. But what if we have to calculate the sum of double numbers? It won't be able to do that, right? Because type is fixed to accept the integer array. So we cannot pass, let's say, a double array. To do that, we have to create another method in the same class to deal with double. We can solve this problem by duplicating the whole code. And let's say this time instead of int, we will return a double output. And this will now accept an array of type double. Like this. So we copied the whole code. All we did, we changed the return type and the type of the array to double. It was integer and now it's double. So we do that and we copy this. Now we will pass double. And this must be double. Okay, so we are calling the sum method, which is an overloaded method, and this time we are passing an array of doubles and we are getting the output in the form of double. For the second method call, we get the double output. So you see the problem with this code. that this code is not able to work with different types. Basically, we had to create, or we had to copy the whole implementation in order to work with a different type, which was double. In case there is a bug in this method, then we'll have to fix everywhere where we copied the implementation. This is the limitation number one, that we cannot work with multiple data types. Let's move on to example number two. This is the example number two, but before that, let me clean the main method. What we are doing, we have a class array to list converter. So we need a way to convert an array to a list. In the same way, we have two methods in this class. One is basically to convert the integer array. In this case, we are using variable arguments instead of the array, but this is same as arrays. So method number one is to convert an integer array to a list. What we are doing in this method, we are iterating the integer array, then we are adding all these numbers to this list. Here you see we are creating list L equals to new array list, and the method returns the list. The second method, which is the overloaded version of the first method, this time it accepts an array of type boolean. So instead of int, this time it's boolean, but we are doing the same thing. So we are iterating the array and we created a new list, then we are iterating the array and we are adding all these values to this list and returning this list. You see the problem, it faces the same problem, that it cannot deal with multiple types, multiple objects, and so it has to create, in this case we have to create the copy of the method. So let's try to use this class to see other problems with this class. Okay. So first we are going to use this method to convert an integer array to the list. So we are going to say ints and array to list converter to list, and variable arguments, which means I can pass any number of values. So I can say 246. And if I print ints and a separator, then we'll call the second overloaded method. And this time this is to store boolean flags. This one, and we'll pass couple of boolean values, false, true, false. So all we are doing is we are calling both the methods with their respective data types, in this case integers, and in this case boolean. And then we are simply printing the list. So we see 246 and false, true, false. Now let's try to iterate this list that was returned by the method. If I do that, if I write a for loop, and because this is going to be a boolean, this list stores boolean values, as we can see from the implementation. So we know if we iterate on this list, then for in each iteration we will get a boolean value that we can store in a boolean variable. Dot get, and then pass the index. Now we see a warning here. It says that required type is boolean but provided object. So we have to cast the output in order to store the returned value in the boolean. That means although we know that in this method we added a boolean value, but when we are trying to get the value back, it is saying that the provided type is object. And so we cannot store it in a Boolean value. To do that, we have to apply this cast. That means we have to explicitly cast this value to the data type that we are going to use. Now we come to the problem number 2. When we use a raw type, then it does not have any information about the type. So you see objects like this when we, let's say, use list in this way. This is called a raw list. And you can see the information on the documentation as well using IDE, that raw use of parameterized class list. So we are creating a raw list. It does not have any information of what kind of objects or values it's going to store. So just to be safe, what it does, it assumes the type to be the object, which is the superclass of all the types in Java. And that's why when we are iterating on the Boolean array and getting a value back, it is providing or it is returning the type object. That is the problem with raw types. And to deal with whenever we are working with raw types, we have to add cast expressions explicitly everywhere in the code. Like this. So even though we know that the method adds the Boolean values, but because this list is a raw list, so it does not store that information. It always assumes the type to be object. So when we need to use the list and when we get a value back, for example, or put a value back, so in that case, we have to add explicit cast expressions appropriately wherever we are using them. This is So we learned another thing, raw types and adding explicit cast expressions to work with them. Okay, moving on. So we have this list Boolean flags, which stores Boolean values, although it has no idea about the type, it assumes them to be object, but we know this list stores Boolean values. So what we can do, we can add another Boolean value here. So earlier there were 3 values, bool, false, true and false. Let's add another Boolean value. This time true again. And we can simply print the values in the for loop. So we can say, and because we added a new value, we should see 4 values on the console. So we see false, true, false and true, 4 values on the console. That's fine. There is one thing that we can do with this list, which is unexpected, but which is allowed because we are using the raw list. So we can add a random value of a different type to this list. For example, I can add an integer. In this case, it is going to be the wrapper type integer. And it won't complain because, as I said, it is a raw list. So it has no idea about the specific data type that it's going to store. Although we know because we wrote the implementation that it's going to be Boolean, but this raw list has no idea. So for this list, Boolean is fine. Adding an integer is also fine. So now you see the problem that there is no guarantee what's going to be in this list. And so we cannot be sure when we are accessing the list what kind of item we will get. This time if we run the same program, we see an exception, runtime exception, which is class cast exception. Although the code compiled fine, there was no compile time error because of the raw type. The assumed type is object, so it allowed all these calls. Compilation was successful, but the code did not work at runtime. It's a runtime exception. When we ran the program, we got a runtime exception, class cast exception. That's the major problem with raw code when we don't use the generics. Now, this is the major problem, which is called the type safety, problem of type safety. So let's summarize the problems that we saw. The limitation number one was to work with different data types. And to solve that problem, we duplicated the code. So there is problem of code duplication. Then because we are dealing with the raw data type, whenever we are trying to access the values from a raw collection or from a raw type, we have to add the cast expressions explicitly, which looks ugly in the code base. And the third problem is because of the raw nature of the type that we are using, the compilation would not complain about the incompatible values, but at runtime we will get a class cast exception, which means the code is not able to handle the type safety when we are using the raw data types. And this makes the software or the program fragile, not resilient, because it can fail at runtime due to the type safety problems that we just saw, the class cast exception. All right. Now that we understand the problem, let's move on to Java generics and let's see how Java generics solve these problems. Okay. If we talk about the Java generics, then Java generics provide a way to parameterize the type in the code base. This means we can write code that works with different type of objects without rewriting the code for each type, or without duplicating the code for each type as we did. For example, we created a method for integer, then we copied the whole thing for another data type, which is Boolean. So if we are using generics, then we won't have to duplicate such code to deal with different data types. All right. In short, or in a nutshell, generics allow us to define a class, an interface, or a method that can be used with different types of object. So we define a class or interface, and we also define one or more type parameters. And using all this, we will be able to solve all these problems as we see in this video. The syntax of Java generics is based on the use of angle brackets to define the type parameter. So if you notice from earlier, when we created a list, let's say this one, then there is no type information, and that's why we said that this is a raw list, because it has no idea of the type that it's going to store. And if we talk about the syntax of Java generics, then we know, as I said, it is based on the angle brackets, and these angle brackets are used to define the type parameter. So where do we use the angle brackets? We use the angle brackets with the class name. In this case, when we are creating a list, we will use the angle brackets and we will define a type parameter. And on the right hand side, where we are calling the constructor, we can simply pass the empty angle brackets because compiler knows the type that it's going to be an integer. So we don't need to add integer here. We can simply use the empty angle brackets and compiler will infer the data type. So this time, instead of being a raw list, it is now a generic list. We say such classes generic class. So this is now a generic list, and this is the parameter, the type parameter of the elements, in this case integer. If we open the documentation of list interface, then here we see the angle bracket and a letter E. That means E is the type parameter. This is a generic interface list, and E is the type parameter which can be replaced with any type when we initialize the list. So in our example, when we created a list, we passed the data type integer, and this E will be replaced by the integer. Similarly, we can use another data type to create a list of Boolean. All we need to do is we need to change the type parameter to Boolean, let's say. So that's how we create generic interfaces or classes. When we create a generic class or interface, we add the data type or the type parameter using angle brackets. And that class will be a generic class. So when we initialize or instantiate that class, we can pass the actual type parameter like this: integer, Boolean, or any other object or data type for that matter. Okay. So let's try to use this knowledge to improve the implementation of the class or the sample that we saw earlier, array to list converter. In this class, we had two methods, one to deal with integer and second method to deal with boolean. Can we improve or can we remove this duplicate code using generics? We know that in order to create a generic class, we use the angle bracket with the class name and we provide a type parameter. So we can do that. We can use E or any other, let's say T. And now we have a generic class. So we are saying that this class is going to be a generic class and T is going to be the type parameter. So when you create an object of array to list converter, then you can pass me a data type. Now T data type, whatever it is going to be, it is on a class level because this is a generic class now. So let's try to write a new method using this data type or this type parameter. So we say public. Earlier we were returning a raw list, but this time what we can do, we can return a list of type T. So we are saying whatever type you provide, I am going to return a list of the same type. Okay. Then the name of method. And here we are going to say that I am going to accept a variable argument of type T. So if you pass me an integer, it's going to be an integer variable argument. If you pass the type parameter as boolean, then this T is going to be boolean. So we will have a variable argument of type boolean. Let's write the body as well. So we create a generic list of T output. Then we iterate this variable argument items. So we say that because this is going to be of type T, so each item will be of type T. This and we can add this item to the list and then we can return the list. Now this is a generic class and we are using generics to write a method that can convert multiple values to an array list. And so we don't need to use these methods anymore. All we can do, we can comment these methods. And let's try to use this class in the main method. So I can say array to list converter, and this time I can pass a type here. So if I want to convert integers to a list of integers, I will say the type is going to be an integer. Int converter equals to new array list to list converter. We don't need to provide the type on the right hand side, so we can leave the angle brackets empty. And then I can simply say int converter dot toList. And if you notice, the IDE is suggesting that this is a method toList which accepts variable argument of type integer. Because as soon as we created the new object and we passed a type parameter, the compiler or IDE can infer the data type. And that's why it is suggesting that there is a single method in this class with type integer. Although if you see the source code here, the type is T. But because we are using generics, so it is able to infer the type as integer, and it's saying that the return type is list of integer, not list of T. So you see the benefit. Here I can say 267. All right. And let's store this in a generic list this time, which is list of integer. Let's say nums. And we can print this list. And this time we see the same output, but This is now type aware. It knows that it's going to be a list of type integer. We can use the same thing with Boolean. To do that, I can do something like this: Boolean converter, and then dot to list, and this time you can see the type has been changed to Boolean. True, false. And if we mouse over, we see the return type is going to be a list of Boolean flags. We can print this as well. Let's run the program. And we see different flags converted into a list. So that's how we create a generic class, and that's how we use type parameters to remove the code duplication to simplify the implementation. So we define a type parameter, then we use that type parameter at runtime. Let's move on to the problem number 2, which was the explicit cast expression. Let's try to check the same thing with flags. This time, if I iterate the flags list and if I try to access an individual element, we'll see that we don't need to use the cast expression. So you see, this time the compiler or IDE is not complaining about the mismatch between the provided and the expected type. Earlier when we did that, we had to add the cast expression explicitly because there was a mismatch. The provided type from the list was object, but expected type was Boolean. But this time, because we created a generic list, so this list knows that it's going to store Boolean values. And that's why when we are getting the value back, it will return a Boolean value. There is no mismatch. So when we use generics, we don't need to add ugly cast expressions in the code base. The code is much cleaner and easier to understand. Now, the major benefit of the generics is the type safety. That means when we create a generic class, we define a type parameter which defines the type of that class. And so the class or the collection knows that it's going to work with that data type only, and the compiler can enforce certain rules to apply the type safety. What that means is, earlier when we created a Boolean flag, because it was a raw list, so we were able to add different types of objects, integer, hash map. But this time, because it's a generic list, it knows the type, so it can apply, or the compiler can apply the type safety rules. And if we try to add incompatible types, then it won't allow. So I can't add an integer value here. It will be a compile time error, which says that there is a type mismatch. It knows that list is supposed to hold Boolean values, but you are providing an integer value. There is a type mismatch. Earlier, we saw that the compilation was successful, but there was a runtime error, class cast exception. But with the help of generics, the compiler can identify such problems, so we fail fast, we fail early at the compile time only, so there are no surprises at runtime. Compiler can detect such problems and it will fail the compilation if we are trying to do something silly or something like this. So till now we saw how to create a generic class, and we used angle brackets with the class name, then we used the same type with methods. Now this is a generic class and this is a generic method, but it is possible to have a non-generic class with generic methods. So let's see that as well. So let's create a generic method in the non-generic class. It's going to be a public method, and I'm going to create a static method. Then we define the type parameter in the method itself. We use the angle brackets and t, for example, that this method is going to be a generic method and the type parameter of this method is going to be t. We can use any other letter, let's say e, that's going to be fine. So let's say t, and the return type of the method is going to be the same t. Name of the method, items, and it must be list of t because we are writing a method to return a list. So list of t, the same implementation that we saw earlier, new array list, then items list.add item and return the list. This is another version of the same implementation, another generic method, but in a non-generic class. So to do that, what we do, we add an extra angle bracket in the method definition itself to define or to declare a new type parameter. So we are saying that this method is a generic method and the type parameter is t. Then we are using that type t wherever we need in the method implementation. This is going to be the return type. We can use the t in the return type. So we are saying that whatever type you provide to this method, I'm going to return a list of the same type. I'm going to accept multiple values of the same type. And the same implementation that we saw earlier. How to use it? We can use the same thing. Let's say to get a list of integer, nums list, I would say converter this time because it's a non-generic class, so we don't need to pass the type parameter here, but to the toList method. So you see, we can call a generic method like this. Compiler will be able to infer the data type. If we print the list and run the program, so we see 3, 5, 6. That means compiler was able to understand that we are going to create a list of integers because we created a list of integer here on the left hand side. But in this case or in such cases, we can explicitly pass the type before the method name like this. We can also pass the data type in this way, but in this case, because compiler is able to understand, so this is basically superfluous that we can simply ignore. But if compiler is not able to infer the data type, then we can pass the explicit information in this way as well. So it comes after the dot and before the method name. All right, but I'm going to remove this. So that's how we create generic method. And I hope you understand what E or T with angle brackets mean now. Next, we'll take a look at the concept of type eraser in generics. We know that if we don't provide the type parameter, then that's called the raw type because it has no type information. So the first list that you see on the screen is a raw list because this list does not have any type information. So it's going to store objects. This one. The second example is list of E. List of E means this is a generic list because it is using the syntax of generics with angle bracket providing E, which is the type information. So compiler knows that this list will store the elements of type T, and while creating a new list, E can be replaced with any data type. So it can be a list of integer, list of boolean, list of doubles, and that's why this is a generic list. But what's interesting is that this type information is a compile time information. So it is available to the compiler, but at runtime there is no generics information available. Let's see how this happens. So what happens, let's say we have a Java program, this one, and in this Java program we defined two generic lists. So one list, the first list is going to store the string elements. So this is a list of string. The second list is going to store integers. So we defined a list of integer a and b. Now what happens when we compile this program using Java C at this step? So Java C is going to compile the whole program. If it finds the violations according to the generics law or some other violation, then it will fail the compilation of that class. That's fine. But if the compilation is successful, then after the successful compilation, the bytecode that this compiler generates, what it does, it simply erases the type information from the Java file. So you see the compiler erases the type information here. And so in the .class file or the bytecode, it will have no information related to the generics. It's going to generate a bytecode that will simply have two lists, list of A and list of B, without the type information. All right. So here A and B, the two variables we created, it's called that they have the same eraser. Erasure means if you remove the generics or the type information, what type you have then. So list of string will have a type simply list. Let's say list of integer will also have the same type list. That is called the eraser of that type. So type eraser means that the information, the generics information that we have, it's a compile time information, and compiler, while generating the bytecode as part of the compilation, will erase the generics information, and while it is erasing the generics information, it's going to insert the cast expressions explicitly as part of that process. So the first example that we saw related to the raw type, where we had to add the cast expressions because of the type mismatch. Now this process is called the type eraser. Let's see how does it impact the code. So here in this example, we have a class type eraser, and then we created two methods. Now you can see that these methods are overloaded methods. The first method is going to accept a list of integers, and it will return an integer array. Similarly, we have the overloaded method that's going to accept a list of string. We may think that because we are using generics, so this list of integer is different from list of string because of this type information. And so this method definition is valid. But you can already see that there is a error that is being reported by the IDE. And if we check that error, it says that list of integer clashes with list of string, because both methods have the same eraser. What this error means that compiler knows that if it erases the type, then both of these parameters will have the same type. That means it's going to be list nums in the bytecode, and similarly this is also going to be list of nums. There is no type information due to the type eraser. Now due to the type eraser, these two methods are exactly same. The type eraser is going to erase the type, and that's why these methods are not considered valid overloaded methods, because their method signature is going to be exactly the same. So this is not allowed. Now you don't need to fully understand the concept of type eraser, but it is sometimes asked in entry and mid-level interview questions. That's pretty much it on the type eraser. In this section, we are going to see subtyping and wildcards in generics. The point 1 on the screen says that S is a subtype of T, which means T is the supertype and S is a subtype. So either it is inheriting directly or via the interface hierarchy. but S is a subtype of T. Point number 2 says that if S is a subtype of T, then an array of S is going to be a subtype of array of T. This relation is called covariant. So arrays are said to be covariant because they follow this relation related to the subtyping. But if we come to the generics, which is the point number 3, then generics does not allow this. It means that even if S is a subtype of T, then list of S is not a subtype of list of T. And due to this relation in case of generics is called invariant, which means generics does not follow the covariant relation as arrays does. They are invariant. So if S is a subtype of T, even then list of S is not going to be a subtype of list of T. They are different. They do not follow this subtype relation. Now let's move on to a simple code and let's see how does it impact the overall coding. So here in this example, we are saying that if S is a subtype of T, even then list of S or any generic type is not going to be a subtype of list of T. It does not have to be list, it can be any generic type. The important thing here to understand is that generics do not follow this subtyping principle. Alright, the second thing is related to the subtyping, that due to the polymorphism that we already know, if a method or anywhere in the code where T is expected, we can use S due to the substitution principle. Now keeping these two things in mind, let's say we are creating a list of numbers. So you can see number is a class that represents all the numbers. So integer is a number and double is also a number. Number is a parent class, a super type for numbers. So we are saying we create a new array list of type number. Now due to this subtyping principle, we cannot say something like this. Even though integer is a subtype of number, but we cannot use the polymorphism here, which means we cannot assign a subtype to the supertype. Alright, because of the generics. So here you can see that this is list of S, which means S is a subtype of T, integer is a subtype of number, but array list of integer is not a subtype of list of number. List of S is not a subtype of list of T. So we need to remember this. If we are creating a generic type, then on the right hand side or wherever we are expecting that generic type, we cannot provide a subtype like that. So this is not allowed. But in this list, we can add any number, which is a subtype of number class. So we can say we can add an integer and we can also add a double. That's allowed. Next, we are going to see what are wildcards in generics that you may see at many places in the code. So let's say we have two lists, list 1 and list 2. So you will see this syntax at many places. What it means that list 1 is going to deal with number or anything that extends number. So it's going to deal with number hierarchy. Now in case of number, we are talking about reference types, which is wrapper of integer and double, primitive int and double. This. Okay. What list 2 means that if we change this relation to super, it means that list 2 is going to deal with either number or anything that is a super type of number. So the set will be defined by the type that we provide here. If we say in general like this, then we are saying that any type that extends T and any type that is a super type of T. Okay. Now, in the same way, you can see a third syntax as well. This syntax means that we don't know the type, so it could be anything. All right. So we saw what is subtyping in generics, what is allowed and what's not allowed, and how to use wildcards. Now there is one more thing to cover before we wrap up this example. There is something called get and put principle. What get and put principle says that you get from extents, all right, and put into super. So according to get and put principle, we will get from list 1 and we will add the values to list 2. That means you should not use list 1 to add the values. It must be read only, and you should not use list 2 to get the values. It must only be used to put the values. What this means, we can write something like this. So what we mean by get and put principle, that we should use the extents to get the elements. So here in this example, in this method, you can see that we are getting elements from list 1, which is using extents wildcard. And the principle says that you should put into super. So here, that's what we are doing here. We are creating a new list using super and we are adding elements to this list. So this is safe. Getting the element from extents and putting the value to super is the safest operation in generics, and that's what we should follow. Now talking about the advantages of generics. Generics provide many advantages, and some of the key advantages or benefits that include type safety, which means generics provide type safety by ensuring that the correct type of object is used in the code. So for example, if I'm creating a list of E, then I'm saying that E can be replaced by any object. So if I create a list of integer, that means that list is going to store only integers. I cannot add any random object to this list, for example, string or double. And type safety ensures that I only add integers to this list, which makes my software, my program more reliable. And if I try to do something silly, that will be captured at compile time only. Okay. Code reusability means we saw an example that if we are not using generics, then to deal with multiple data types, we often have to duplicate the code. All right. But if we are using generics, then we can combine the functionality using type parameters and we don't have to duplicate the same code repeatedly. We can reuse the code. We can write a generic implementation to deal with multiple types. If we talk about the performance, then generics can improve the performance of the code base by reducing the need of typecasting. So if you remember the example of raw code, then we saw that, let's say if we create a raw list, then if we are trying to get the element back, even though we know that we added, let's say, a boolean, even then we had to add a cast expression explicitly that convert this into a boolean. And all this can be avoided using generics. So it speeds up not only the compilation but the execution of bytecode as well. Now that's all from my side on the topic of generics, and I hope you found this video informative and useful. As always, if you have a question or comment, please leave them below. Thanks for watching.